My name is Serhat, and I work at Atlassian. So I actually work for Opsgenie, but they acquired us a year ago. So now I work for Atlassian. I'm working as a technical evangelist. I used to be a software engineer. Worked on different parts of Opsgenie. Had a lot of experience working with cloud. I'm also an AWS community hero. And I also organize a lot of events. So I'm part of DevOps Days global core team, and I help organize some local conferences in Istanbul, where I live. DevOps Days Istanbul, Serverless Days Istanbul, and so on. So that's all about me, and today we are going to talk about serverless. And when I saw this stage, I wasn't sure, I really wanted to do this one. I mean, this is a great stage. It's very suitable for this kind of craziness. But I didn't have servers with me. So before we start, so I want to ask, who thinks serverless is a buzzword? I mean, not as much as blockchain or AI for sure. Okay, just one? Really? I mean, serverless is still misleading and still can be considered as a little bit hype. And people use different things while describing it. I mean, that is also very confusing. Anyone wants to describe, say something about what is serverless? Okay, so let me ask this first. So how many of you are using cloud, like AWS, GCP, Azure? Nice, a lot of people. That's great. And how many of you are using AWS? Okay, that is good. That's better. Okay, awesome. Because I'm going to mostly talk about AWS Lambda. I'm going to make a short introduction because I see half of you still don't know much about AWS or specifically AWS Lambda. So there will be a short introduction to Lambda as well. So let's first try to describe what is serverless. I mean, I'm not going to make the old joke but I mean, this explains it very well. It is still serverless the same way Wi-Fi, it is a serverless the same way Wi-Fi is wireless, right? I mean, I'm not going to go on into this there is no service thing. So there are two definitions. Actually, when we see people describing serverless, even within the AWS community, there is no one true definition. People come up with their own. It's still a misleading term no matter what we do, and it's going to stay that way. But there are two widely used definitions as far as I see. And the first one is seeing serverless as a way of creating customer value. I mean, that is the whole point of creating software, right? We want to create customer value, and they say serverless helps. Serverless is not just about lowering operations or managed services or just using AWS Lambda or just using a couple of these, what they call serverless or sometimes called fully managed services. They say it's about creating customer value faster. And they have a point. They have a great point. And the definition 2 says serverless is an event-driven. So this is from Simon Wardley, famous, with the Wardley mappings. Serverless is an event-driven, utility-based, stateless code execution environment. So this is I think, more structured definition of serverless. Competing what we think about serverless, I think we mostly think about this one. So I want to break down these things a little bit and what we mean by each of this. So when we say event-driven, we mean code is initiated and run after an event like HTTP request or storing a file triggers. For example, if you are using S3, simple storage service, you put documents there, right? You put objects there. When you put an object, there is an event like create object event, for example, and you can trigger AWS Lambda with that event and do whatever you want. For example, there has to be some sort of trigger. Also, it is utility-based, which means there is no payment for idle time or hosting. If you don't trigger your code, if it doesn't run, you don't pay anything. And the third one is it's being stateless. So its code execution environment is deconstructed after some time. So if you don't make requests, I mean, they keep the code execution environment alive for some time to fasten the code execution, but it is all destroyed after some time. I mean, there is some specific things going on there, but overall what we need to know, it's a stateless environment. you can't store data there. I mean, you have to persist data to to a persistent storage database like DynamoDB. It can be MySQL, whatever database you use. So it's a code execution environment. When you say it's a code execution environment, it is really like narrowing down. Then you have Lambda, AWS Lambda left. If you don't say code execution, if you just say event-driven, utility-based, stateless, you might think about DynamoDB as a serverless solution as well, for example. It is, again, like just code, not dealing with servers, VMs, container, any of this. So I think just combining these two things and just making it simpler, we can say serverless is a cloud model where you pay only for the time your code is executed and focus on providing business value, not managing your own cloud environment. And believe me, it's a big nightmare. I mean, if you work in a big company, you probably have some experience as well. It's a big nightmare. It's not easy to manage all this cloud complexity. We will see if it is actually easy or not with serverless. There are some bad parts as well, as I shared in the title of the talk. But normally I like to talk about why, like before what. But in this case, we didn't. We probably had like confusing ideas about serverless. I chose to talk about what first. Now we can talk about why a little bit. So there is great inefficiency in how we run software today. Like, I mean, do you know how many people spin off a new VM to run a bash script? I mean, I don't know either, but I wrote a couple of scripts just, and create a VM and run it there. I mean, you don't really need to do that anymore. It's just, just running something for a couple of minutes, just one time a day, or just, a couple of times in a minute should not be, like, we should not create a VM and run it whole day to be able to do something like that. We should not pay all the money just to run a bash script. It's just one example, but there is great inefficiency. I mean, if you think about global scale enterprises, there is a lot of idle resources waiting there and doing nothing. And when you think about it, it's not just about idle resources. It's also about the human resources. We have this thing called DevOps engineers. Probably it's not a real thing, right? But they do a lot of things, right? They do automate things. They create our CI/CD. They do a lot of monitoring. They provision our servers. They patch our servers. They do a lot of things. And none of this actually has nothing to do, most of the time, has nothing to do with what our real business, it has nothing to do with our real business. I mean, if it's your AWS, obviously, AWS Lambda is not on-prem for you, is not on-prem for you, it's not serverless for you. But unless you are AWS, I mean, you don't really need to do a lot of those things. So one good example is about like explaining why. This is from Ben Cohe. He's AWS Serverless Hero, and they have the iRobot has this vacuum cleaner, and they sell this vacuum cleaner especially on Thanksgiving. So all of these machines comes online in a 4-hour window, basically, on Christmas morning. So they see like 100x spike on the all requests. And their engineers actually can sleep well. Like they run everything on serverless, so it will scale automatically until that point. And there is another example. I watched this talk in London like 2 years ago. Dizzy, he was the VP of engineering for DigitalOcean. And he was talking about how it would be a lot easier if their customers were running on a serverless environment. Because this Meltdown and Spectre bug, the famous security bug, caused them like so many issues. It wasn't just about them. Their customers also had to take manual actions, so it took a lot of time to actually fix those bugs. But if it was just a serverless environment, just like in AWS Lambda users, AWS fixed it and the customers didn't need to do anything. It was just working. It was AWS responsibility. Basically, you outsource some of these responsibilities to the cloud provider with serverless. So if I narrow down why serverless important? I think there are two important things. And the first one is basically because less is more. So we have with serverless environments, we have less code to maintain, less operations, less what we call toil in SRE terms, site reliability engineering terms. Until some point, we do not care about scaling. I mean, there are some specific issues. I will talk about them. We do not care about provisioning servers. We just, package our application and upload it. We do not care about operating system or language updates. We do not care about resource utilization. It just, your code runs and it ends its execution and it's just deconstructed. Network monitoring is not a real thing there. I mean, we don't care about fault tolerance. Our functions are deployed into multiple tree availability zones, actually, by default. And we do not care about shipping logs. Wherever you write, like if you write system out, I mean, it will go to the CloudWatch by default. And the second thing is there is no payment for idle time. I mean, that is huge. That is something we have never seen before. I mean, the one I talked about before, it is also obviously about economics as well in some point, because you will not hire a lot of engineers just to do all those works. Also, serverless is relatively easy to get started. I mean, if you're a developer, you can just spin up a function and just do something in just a couple of hours. You don't really need to have what we call obstacles, right? A lot of obstacles. But it is not as easy as it is not easy to master. I mean, there are some. It can get really complex at some point. Again, we are going to talk about those. It is relatively easy to put on production, so it is faster to market. I mean, you can try new things faster. You don't know whether they're going to really work or not. So you can just try and if it doesn't work, it doesn't work. You didn't spend a lot of time. So before talking about what I call key takeaways, I want to make a short introduction to AWS Lambda for those of you who don't know much about it. So when we think about cloud computing today, we have these options. We have bare metal. I mean, you do everything with bare metal. We have virtual machines, infrastructure as a service, in AWS terms, EC2, as most of you know. Containers as a service. Within those things, we now have managed container service, AKS Kubernetes service, kind of things. We have apps, platform as a service, what we call Elastic Beanstalk. We have functions, AWS Lambda. Functions as a service is a better name for it than serverless. Now we also have something called AWS Amplify, basically a framework on top of these, what they call fully managed services. So it is easy to create web and mobile applications with AWS Amplify, but it really narrows down the possible use cases. So it is still useful. If you want to just create a CRUD website or mobile application, it's pretty useful. Not to deal with all those complexity around AWS Lambda. Yes, it is complex, even if it's serverless. So AWS Amplify actually covers some of those use cases as well. How it works is it's just a high-level view of AWS Lambda. So you write your code. It's just you implement this function, and you package it, and you upload your code to AWS Lambda environment. And then you set up a trigger. It can be, we are going to talk about those, a lot of different things. And then you trigger your code. It runs. It ends its execution, and you only pay for the time you use. We already talked about this a little bit. And how it works internally. So this is a pretty simple version of how it works. But there are containers underneath. You don't really see them. Oh, nice. Okay, so you make a request, and if your code run before, there might be a container available just waiting for your call. And if there is a container, your code runs immediately. There's an empty container waiting for you. If there's no empty container waiting for you, this is all invisible to you, by the way. There is no container waiting for you. They create a new container, and they spin up a new container and run your code. So this adds additional time for running the function. This has been a big issue within the serverless community, and you probably heard the term cold start. This is why this cold starting happening. but they make great improvements, and I think they're going to announce a lot of things about this, like improvements, especially around VPC at re:Invent this year. So when they first started, it was just Node.js, Python, and Node.js and Python, and they added new languages all the time. There are different versions of these languages as well. We now have Node.js, Python, Java, C#, Golang. We also have what they call bring your own language. Now, actually, you can now even use Bash scripts, PHP, whatever you want. It is fairly easy to use the language you want. And we talk about pricing a little bit. Just run your code. It's over. It's not just that simple, obviously. So you choose the memory size. That is the only thing you choose. So it starts with 128 megabytes up until 3 gigabytes. And so the number, like the percentage of CPU they give you, it depends on how much memory you choose. So if you double the RAM, they will also give you, they will also double the CPU that they give you. And there is one trick, you have to know this. It is important if you are using Lambda. So more memory doesn't always mean you pay more. What do I mean by this? So it is about the CPU thing. So if you run this code, for example, you are calculating stats for Lambda function with all prime numbers, 1,000 times up until whatever. It's a big thing. You are doing a lot of calculation. So you need CPU. So if this happens and you run your code with the lowest number, 128 megabytes, it's going to take about almost 12 seconds, right? You are going to pay $0.02. And if you use 1 gigabyte of memory, it's going to take about 1.5 seconds, and it's going to cost you almost exactly the same thing. So if your load, what you do is CPU, needs CPU, then you might think about increasing your memory. And there is this trick as well, if you run your code with, for example, we use Java heavily at Opsgenie, and if we run our code multi-threaded with 3 gigabytes, so 3 gigabytes you get 2 cores. So after 3 gigabytes, with 3 gigabytes, you actually need to make use of the threading. If you don't, you basically lose some resources. You don't use some resources. So there are 20 plus services that can trigger AWS Lambda today. I will not go into the details of these, but basically nowadays, if they have a service that can create events, which most services obviously can create events, they integrate it with AWS Lambda, which makes it very easy to connect different AWS services and do things after something happens. Now it's more than 20 services. It's increasing every year. And there are different tools around AWS Lambda. For example, for orchestration, we have step functions. It was not that mature before, but they are adding new things every month or so. So it's getting better and better. We have for deploying your code. Obviously, you shouldn't do that manually all the time if you are doing something in production. So we have SAM. Basically, SAM is AWS's default recommended tool for deploying serverless applications. We have Serverless.js, CloudFormation, Terraform. Obviously, you can use those as well. If you are, most people use EC2 containers and Lambda together, so it might make sense to use something like Terraform, for example, if you are already using it. And for monitoring, we have X-Ray, CloudWatch, and some third parties, and we are going to talk about those a little bit later. There is also a marketplace called AWS Serverless Application Repository, which is basically, so I created this demo for re:Invent last year. I just, wasn't sure what to do, so I went to this marketplace repository and pick up 2 Lambda functions, just click a couple of things and just configure it with keys, and it just works. It's actually pretty cool, but it probably may not work if you are doing something big. But if you want to just try something, or again, it's a good place to learn about these things and try and actually experiment with Lambda. So now we go over the kind of boring parts. Now I'm going to talk about some of our experiences. But before do that, I think for you, like if you know what we do, it might make even more sense for you to see like why we want to use serverless tools. So I work for Opsgenie. We are an on-call incident management solution. So we help our customers to stay on. Like we help run their services run always on. I mean, that means we have to be up and running all the time. So it is not just a competitive advantage or anything for us. So it is basically a must. So we have to be up and running all the time. So we basically have this mentality that if like AWS has a managed service for something, we use it. We don't host it ourselves on EC2 because we don't want to manage all this complexity. Our time is we want to focus on the new features. We don't want to focus on running these, like for example, EC2 machines. Like we have EC2s, but we don't want to like focus on managing MySQL, for example. We want to use RDS, so it has automatic backups. Like it's redundant by default. So a lot of things are already there. We don't want to deal with those. And really, we cannot find experts for each of these areas. It's really hard. It's really expensive. I mean, at first, when you look at some of these services, AWS might look like expensive, but when you think about real costs, it probably is not expensive. And we use different services, like more than 30 different services, I guess, if you consider security services, etc., everything. But mainly, when we think about managed services, we use DynamoDB heavily. Most of our data, if you don't count business intelligence part of Opsgenie, is in DynamoDB. We use SQS. We use some Lambda. We use RDS with Aurora, EC2, ALB, Kinesis, SNS, and some other tools. We are using Java 99% of the time. There are some small scripts maybe written with Python, and we have SDKs for our APIs, but that's all. I mean, all of our infrastructure are written in Java. So our serverless journey is started in 2015. So writing small-scale custom integrations, what I call. So at this stage, basically, we started like leveraging Lambda to help our customers run custom code. For example, like there is an alert, they get a notification from us, and they want to run something when that thing happens, and we don't want them to. It is really hard for them to like spin up a new container or EC2 machine and keep it up and running all the time. It also costs a lot of money. So this is the perfect use case. If something happens in Opsgenie, if they want to run a code like after that event happens, we recommend them, if they're an AWS customer, we recommend them to use Lambda. So in 2016, we saw the first usage of AWS Lambda internally in Opsgenie product. So at this stage, we started leveraging Lambda with some asynchronous, what we call not very business critical services. For example, DynamoDB Autoscale. I'm going to show you the architecture examples of these. Some of these. Basically, they were not very critical jobs. So you want to take a backup. You want to do like something not very important. It doesn't have to be happen in the time. So we start using creating some small Lambda functions. Then we started to actually go a little bit bigger. I mean, Charizard is always a little bit of trouble. So it was a little bit of trouble as well for us. So we decided to create this new incident management feature. Basically, we group alerts under incidents. So it's kind of a abstraction on top of alerts. So we decided to create this feature running fully on AWS Lambda. So that is where most learning happens. And then we saw that there is no real monitoring tool that actually is capable of really monitoring AWS Lambda internally. Like you don't know how much time you spent on a function. You can't really say without writing a lot of code what happened in a Lambda function. So we built this tool internally. So with the Atlassian acquiring Opsgenie, so Tundra basically spun off, became another company. So they are doing observability for AWS Lambda now. So now, let's talk about some of the key takeaways. So takeaway 1, serverless doesn't remove the need for great engineers. What does this mean? So this is an example architecture from, it's really not that big of an architecture. I mean, I assure you that there are a lot bigger architectures. This is a post from Yankui. So it can get pretty complex. I mean, you see, you use a lot of different tools. It's just, really hard to know what is going on in those complex, a lot of tools, a lot of different functions. It's like microservices, but it might even be like smaller services. So it's a lot of tools. And there is a learning curve for going fully serverless. It's not easy again. You have to know different tools. You probably don't want to use, you probably want to use managed services, and they have all these tricky things that you really need to know if you don't want to be down. So it is not easy. So you have to spend some time learning those tools as well. I mean, there is a real learning curve for Lambda. That is something I think AWS needs to fix somehow, because that is my observation. And again, if you want to do Lambda, you probably need to do microservices, right? You have to create small functions, and then you are kind of doing microservices by default. And it might make sense to do microservices by default if you are just starting, for example, and with all this complexity of microservices comes with Lambda as well. So you have to do you have to event-driven everything. Everything has to be event-driven. This is often something that we are not used to do. So you have to think that way. And inter-function communication is kind of complex. You have to decide how you should communicate between functions, whether you use SQS, whether you use SNS, whether for some things, whether you use DynamoDB streams. I don't know, whether you use API gateway. Then there is cost concerns. There is I don't know, the API gateway has 30 seconds limit, for example. There are a lot of limits that you need to consider about if you want to decide what to use for inter-function communication, and it really depends. And this is the kind of thing that I talk about, complexity of serverless, learning curve of serverless. And functions should be idempotent. I mean, if you make more than one request, it has to give the same result. So which means and we've seen 3 or 5 times the same request comes from AWS. It shouldn't come, but I mean, it does. So you have to be ready. So that means you have to go and check from, for example, Redis, and see if you already processed that request for every request. I mean, that is not something ideal, obviously, but you have to think about these things. And it is stateless, but you can actually, for example, if you use a MySQL kind relational database, you have a connection pool, and just creating the connection pool takes a lot of time each time if you create it. So you can cache it. If the container doesn't die, you can use it, reuse it. But then you have to think about those cases and build your application considering those cases. I mean, it's a lot of work. You want to just focus on the code, but it's not exactly just code. So you really need great engineers, just as always. And with Lambda, considering you only pay for the milliseconds you use, for every 100 milliseconds you use, then you start thinking about things that you don't think before. I mean, with EC2, you don't think about seconds. It's okay, if it takes a couple of more seconds, right, for some things. But with Lambda, you're going to pay more. And if you are really executing your function a lot, it actually might be significant. So you are adding another concern. I mean, again, you still need great engineers. And maybe you heard about this no-ops term. Obviously, it's not a real thing, but serverless is what I call less ops. I think it fosters this idea of you build it, you run it, so developers actually can take more jobs, take on-call duty, take on responsibility of monitoring functions, deploying functions. So it is easier for them to do all those ops things because most of them are already covered by AWS. So I want to give you one example about this less ops thing. I mean, there is still ops. We had this incident with $4,000 with 2 weeks. So we have this. At the time, there was no SQS trigger. So we had this environment. This was in development environment, by the way. We didn't have alerting for pricing at the time. And this was a developer's environment, so we have this gray log, and our Lambda function incident monitor log makes a request to Greylog is down, request fails, and then this goes to the dead letter queue, what we call. So basically, if your function fails, your payload will go to the queue, so you can have another Lambda function listening to those queue. In this case, we were polling because there was no trigger for SQS, but anyway, it's the same thing. So you get the payload again. So we trigger the function again. So this was an infinite loop. This ran for 2 weeks, and the cost was $4,000. We talked with AWS team, so they pay back most of it. But I mean, I would understand if they didn't give it back because we actually use those computing resources in this case. I mean, it is easy to figure out like if you didn't use an EC2, if you just forget about it. But in this case, we actually used it. So some of the lessons learned. I mean, Unity avoid infinite retries. Unity monitor and alert for pricing. This is pretty important, but there are some tricks. Like there is no, for example, pricing metric for AWS Lambda on AWS still. So you have to figure out that on your own, write some code. And you need to think about CloudWatch costs and sample log some metrics. I mean, if you make a lot of requests to CloudWatch, it will cost a lot. I mean, one time we realized that we are paying like $1,000 just to make API requests to CloudWatch logs a month. Yeah. So again, you need to build still your delivery pipeline, deployment strategies. You still need CI/CD. But it is easier with AWS tools. We have cold starts, but there was this huge effect coming from VPC, using VPC. If you want to make your Lambda more secure, basically there is a big latency because of like how internal things works with VPC and Lambda connection, but they are actually fixing it. So it's not going to be an issue soon. So it is marketed as like infinitely scalable solution, but it has some not hard limits, but limits. So if you, for example, we hit that limit once. So if you hit that limit, your functions start failing, actually. So let's say, by default, it is 3,000 concurrent execution requests. So I will not go into the details of those. I don't have time. But basically, it depends on your memory, how much memory you use, and how many requests you make every second. And there is this calculation. And if you reach out to this 3,000 number, basically AWS starts throttling you. And if you want to increase that number, you open up a ticket for AWS customer service, and they hopefully increase your limit. And there are some bad things going on there as well. Again, like I don't have time to go into the details, but we can chat afterwards if you want. And monitoring has to be a first-class citizen. I mean, again, like pricing is a concern. So if you are spending a lot of time on just one of these functions because of like some bug, you want to know that, right? And it wasn't easy. So fixing it is slow. Definitely was harder for AWS Lambda. We have this heavy monitoring need because we want to solve the problem as soon as possible. That is very critical for us. So it wasn't easy. So some of the problems were there were too many moving pieces. I mean, there are a lot of different functions talking with each other, talking with different AWS managed services as well. And there was no way to attach an agent. I mean, we were using Java, but because it is all managed by AWS, there were no way to, like, for example, we were using New Relic at the time. There was no way to attach the agent. And also the pricing of most monitoring tools, almost all of them, basically wasn't suitable for something like AWS Lambda. It was something new. And even like how to send the monitoring data is a discussion point. For example, those tools usually collect the data and make the request at the end of the request. I mean, if you do that asynchronously, you might lose some monitoring data. If you do that like synchronously, it will increase your request timing and it will cost you more. It will cost you more anyway. But what we do here, for example, with Tundra, we started doing for production, we started doing asynchronous sending of monitoring data. We write everything to CloudWatch. So there is another Lambda function listening to those CloudWatch logs and sending the data to Tundra. And with Tundra, we are able to instrument the function and even go like variable level and see how much a function took and take actions on, like see how much time we spent in each layer, and even see what is going on within a variable. And later, Tundra team also added distributed tracing. So if you are sending a request to DynamoDB from their connect the DynamoDB streams to another Lambda function, make a request to SQS, so you can actually trace all of this and see in one view with Tundra. And all of these like logs, they bring logs, traces, and metrics all in one view. So it's a pretty cool tool. So if you are using Lambda, I suggest you check them out. And also serverless is usually cheaper. One of the examples from us, I mean, this is, I think, a good example to share with you, like, it is not just about the immediate cost, like the cost you see on the bill. With this one, so at the time, DynamoDB didn't really have any way to replicate the data to another region. So DynamoDB didn't have global tables, what we call, basically distributed across multiple regions. So we had to do this ourselves. We wrote one simple Lambda function, almost like 20 lines of code, and it was listening like gigabytes of data every second and writing it to another region. It's just that it scales automatically. If we get more load on DynamoDB, Lambda also scales automatically pretty well. So think about just running something on EC2. I mean, you have to think about a lot of things to ensure that it's running smoothly. But it's pretty easy with Lambda. And also it's pretty fast. I mean, we didn't really need all of those DevOps engineers to automate all of this. So Lambda has also free tier. There is 100 millisecond based pricing. Again, like fighting good engineers is hard. Probably like it is really hard to find what we call DevOps engineers nowadays. And there is this also total cost of ownership. There's no initial investment. You just go ahead and use it. Less maintenance cost overall. Less engineering workforce cost. And you're probably not Spotify and Netflix. So, I mean, if you have that kind of scale, you might think about building your own thing. I mean, if you are Netflix, you might probably think about like keeping your data someplace else if it makes sense. But still, even they keep their data on cloud. Most of their things on cloud. And there's this misunderstanding of like serverless is just for a couple of things. It's just connecting simple things. And I get that because it is not really easy to like learn all the details. There are a lot of things going on. It's not just Lambda. But it has actually many use cases. It can support many use cases. This is one of the examples of an integration with Obscene, for example. So there's a Slack message, and Slack has this outgoing webhooks. So if there's a Slack message, Slack can make a request through webhook. And we have through API gateway service of AWS, we have an API endpoint. So Slack makes a request, API endpoint triggers Lambda function. So within that Lambda function, we can do whatever we want now. So we can create an alert. I mean, we can go ahead and check our logs and create the alert with some enriched context. We can do whatever we want. It's pretty simple, and we don't really need to do anything. Like it just runs. Again, like if someone writes a Slack message, there is no EC2 machine waiting. We are not paying anything at that moment. So it's one of the best use cases, I think. And one of the examples from Obscene, we are still doing DynamoDB autoscale ourselves. We are not using AWS's default autoscale mechanism. There are a couple of reasons. I will not go into those details. But basically, for example, you can only downgrade your tables like 4 times a day. There are a couple of restrictions. So you have to obey them and ensure that your app's still up and running. There are some tricks. So we have this autoscale Lambda basically checking DynamoDB. We have like some information about each table. And we check CloudWatch as well. And if we want to update it based on the CloudWatch metrics, we update it. Or in case of we want to do a migration and increase capacity for some time, we can trigger the change from Slack as well. Just update the Lambda function, update the config table, DynamoDB streams. This is a DynamoDB table. Through the streams, we trigger the autoscale Lambda automatically, and it just does things and update the table automatically. We also, in the meantime, update the CloudWatch alarm just to ensure we don't get any false alarms from CloudWatch about the DynamoDB table capacity, for example. And this is just overview of our service and incident management solution. There are a lot of Lambdas. Some of them, we call them through EC2 instances. So most of Obscene are still running on EC2, but obviously it's full automated. in this case, again, like we have some SDKs through some of these teams use these SDKs to trigger incident actions, and all of what happens with an incident is just all Lambda. And they talk through, some of them talk through SNS, some of them talk through SQS triggers. And we tried to use API Gateway for some time for our public API for incidents. There were some problems with API Gateway, so we don't use it now, but we use it for a while as well. So again, FaaS is great for connecting stuff on the cloud. It is just perfect. I mean, if you are already on AWS, it's just deploying a couple of seconds. It just runs automatically. You just pay when you use it. It's great. So there is support for bringing your own language. We already talked about this. Interestingly, so API Gateway also now has a support for WebSocket. So you can actually do some real-time things. So it's event-driven thing a little bit changing with this addition. And again, like the goal is not to use serverless. So if there is some specific service that is doing the same thing, I don't know, if you are doing, let's say, image recognition, I mean, or just doing something with S3 based on a trigger, use those services instead of Lambda. So again, like if there's a managed service that is covering your use case, use those services, not Lambda. It's because it's all about focusing on creating customer value. And there are some common use cases, like when you think about Lambda, when you search for Lambda, you will see ETL jobs, because like stream processing jobs, it's all basically event-driven use cases, or building APIs. If you make a request, that's also an event-driven use case. And we talk a lot about this, like vendor locking, but it is all about creating a customer value, so you don't really want to care about most of these things. Obviously, if you are a big company, you have to think about those things. But especially if you're a small to medium company, it is not, your main job to focus on those things. Just evaluate your cloud provider based on a couple of things, but don't think about cloud locking from the start. So we talk about 5 key takeaways, actually 4 plus 1. We still need great engineers. We have a lot of different things to do. It's just complex environment. We have less ops, not no ops. There's still some ops things, what we call monitoring of our functions, deploying our functions, CI, CD, etc. It is cheap, and also it removes the need for some operations jobs. So we actually save some money, obviously, from engineering power. It is capable of covering a lot of different use cases, not just tying a DynamoDB table to a Lambda function and doing just simple things. It works very well for them as well, but you can create bigger things with Lambda. And vendor lock-in probably isn't your first concern. So, customers don't care if you run on bare metal containers, functions, or whatever, right? They don't care. They don't know if some of the Opsgenie parts run on functions and service. They care about our feature, our uptime. We care about our uptime as well. So we don't want to really own a lot of those things. If AWS already does those things for us, we use what they provide. Obviously, we still need to do a lot of things to ensure that we run reliable on cloud. It's not easy. But still, a lot of concerns are outsourced. And I really recommend this white paper from Berkeley University. So they conclude that serverless computing will become the default computing paradigm of the cloud era, because I believe, cloud, serverless is what we want, actually, from cloud. Thank you very much.